Hi, my name is Matthew Barnett, and I'm a part of Group 2. This is our group project on Piaget's developmental stages. We chose the concrete operational stage, which ranges from children 7 to 11, and we chose to test their conservation of liquid volume, or their understanding of the conservation of liquid volume. So, Jean Piaget's theory of cognitive development outlines 4 different stages of developmental and intellectual growth. Like I said, the stage we chose is ages 7 through 11. It's where children begin to think logically about concrete events so they can understand change. This is the stage our group chose to test. Conservation will be our key focus during this experiment, meaning we're testing whether the quantity remains the same despite changes in appearance or in shape. The design of our experiment is to test their ability to understand these changes in concrete events. The experiment that we designed was to test each child's comprehension in this area. There's 5 members within our group, 4 of which conducted the experiment, and I've compiled and put together the information and I'm giving the introduction and analysis. The 4 students, or the 4 members of our group that conducted this experiment were Maya Hampton, Courtney Reno, Jermaine Smith, and Kendrick Slaughter. They performed this experiment with students either at school or kids that they had at home. So there were 2 groups that performed it with classes at school, and the other 2 performed it with their children at home. Our hypothesis was that the majority of students in our experiment would recognize that the amount of liquid stays the same when it's poured from glasses of the same size into different shaped glasses. This would show that they understood the concrete evidence, or the liquid, stayed the same even though the different glasses were used. We hypothesized that they may miss it at first, but given a second chance, they would understand once you poured the liquid back and forth. There was a control that was used to measure that. We had 2 identical glasses with the water level and then would pour it into different glasses. It was done a little bit differently in each experiment with whatever glasses each member had available. After making their prediction or their first guess, the students were given the opportunity to change their answer. Our experiment did contain some outliers, as we had students who fell outside of this developmental stages range. There was a student who was 5, I believe, during the test, and as well as a student who had learning disabilities. However, as you'll see, our hypothesis was proven true that most of the students were progressing within this.
Hello everyone. Today I will be conducting an experiment with my 6-year-old daughter. She will be 7 in November, and the purpose of this experiment is to determine whether children understand that the quantity remains the same although the glasses have changed. So Melody, I'm going to ask you a couple questions, okay? Okay, so you see these 2 glasses right here?
Yeah.
Do they have the same amount of water, yes or no?
Yes.
Okay, you say yes, okay. So I'm going to take this glass of water and pour it in here.
Pour it.
It's okay. Pour it all in there. So now I'm going to ask you, does this glass have more, less, or the same?
More.
Why do you think this glass has more?
Because it's all the way up here and this one's all the way down here.
So are you stating it's more because of the glass change? Like, this is a taller glass, or?
I'm saying it because this is a tall glass, so it gives it more water.
Okay. Are you sure?
Yeah, because it's a taller glass, and if you want to reach up here, that's fine. Right here, that's fine too.
Okay. But you remember, I just poured this water in here. So it's the same, right? Okay, so let's do it one more time. Okay.
I messed up.
No, it's okay. Come on. So again, do you think this cup has more, less, or the same as this cup right here? The same. Why do you think it's the same?
Because you already poured that. You already poured this glass of water in here, and then it made it even taller.
Okay.
And then if you pour...
Okay, thank you. Thank you so much.
Bye, y'all.
Ask you guys a question. If I was to pour this green liquid into this cup, will it be the same amount as what is in the pink cup, or will it be more? What do you say? Hold on. Calvin, you think it'll be less or more? Or the same?
Should we pour it into that?
If I pour this, sit down.
Like the whole thing, or just
Yeah, if I pour all of this green into this cup, will this cup be the same as the pink? Will it be less or more?
It would
Calvin,
be the same
age
because those cups are big.
Just say
Said same.
What do you say? Will it be the same? If I pour the green into this cup, will it be the same as the pink? More?
Caden, age 5, said more would be in the taller
What do you
glass.
say, Katie? Will it be less or more if I pour this green liquid into this cup? Will it be the same as the pink cup? More or less?
Cadence, age 6, said less.
Ian, what do you think?
Ian, age
More?
7, said more.
Okay, and so now I'm going to pour the green into this. It's okay. It's okay. It's okay. Just a little spill. So now you think that there's more green than pink in this cup.
Yes.
So
But you're wrong.
in the beginning, I had these two, and the green and pink were the same, correct?
Yep.
Okay. So now your answer is still the same. You think there's still more in this cup than there is in the pink?
Yes.
And you think there's more in this cup than there is in the pink? And you think there's more, but you think they're the same. And we agreed that the pink and the green in these cups are the same, right? Okay, so when I pour it back,
It will be more. This will be less.
so these two cups, are they the same or different? Are they the same? Is the green and pink the same or different?
Different.
Okay, Katie, are they the same or different? Same. Kaden, same or different? Different? Same. Okay, why do you say that they're the same?
Because they're.
Calvin, age 10, provides explanation for both being the same.
And then you just added the dye to change the taste and the color, and that it doesn't add anything else. It just makes the color and taste different.
Okay, why do you think they're different? Since I poured them back, why do you think they're different and not the same? No answer's wrong. So, tell me why you think they're different.
Caden, age 5, provides explanation
Okay.
why
And you say
they
they're the
are
same.
different.
Why do you say they're the same?
Katie, age 6, changes her answer
And
to
you say they're
being the
different?
same.
Yeah, Blaze says they're the same.
Ian, age 7,
Okay,
changed
why do you
his
think they're
answer
different?
to same. I would like to add, he is autistic and needed a more
What about
literal
the measurement of the cup?
explanation,
So when I put
which
this
I
liquid from this
discussed
cup
off
back into
camera.
here, are they
He
the same
meant
now or are they different?
that the colors
Why do
were
you think they're
different. However, the amount of liquid within both
Okay.
jars, even in switch to the tall one, were both the
Alright.
same. So
Well,
his answer,
for
just like
participating in my
Caden's,
little
was
science
also
experiment.
changed to same.
Okay, Caleb,
Okay.
introduce yourself.
Hi, my name's Caleb. I'm 9 years old. When I turn 10 in 4 months.
What grade are you in?
What?
What grade are you in?
I'm in 4th grade.
Okay. Now, which one of these cups has the most water, the least water, and the middle of water? Which one you think that is?
I think this one has the most water,
Mm-hmm.
the least water,
Mhm.
and the middle.
Okay. All right, let's see. Okay, so now we're going to bring this in and we're going to pour this one in there. Okay.
It's 2 cups, it says.
As you see, this says 2 cups. Let's pour this back in there. Okay. Right here, The middle one has
2.5 cups.
2.5 cups. Let's pour this back in there. Okay. This one has
3 cups.
It has. You sure that was? It says 2.5 right here.
It says 3 cups from my side.
It says 2 from my. Oh well. Okay. So now that you've made your decision and you made your answer, and since you've seen how much water is in each one, would you like to change your answer, or are you gonna stay the same?
Stay the same.
You gonna stay the same? Okay. Well, say bye-bye to the camera and say we'll see you next time.
See you next time. Bye.
Okay, raise your hand if you think it's the most. If you think red is the most. Raise your hand if you think red is the
Raise
most.
your hand if you think red is the most.
Are you sure?
All right, 2 people.
Cause then right here too. Oh, wait, what?
All right. Raise your hand if you think the smaller glass has the most.
Me. I think it's
1, 2. Oh, everybody not raising their hands.
the same.
All right, let's go back. Who
So we
think-
got how many choices we gonna have?
We just have one choice. Actually, 2 choices. Either the bigger glass has the most, or the smaller glass has the most. Which glass do y'all think has the most water in it?
The red.
Okay.
The red.
So raise your hand if you think the bigger glass has the most in it.
Me. Which is
Raise your hand. Raise your hand if you think the red has the most. 1, 2, 3, 4. Okay. 4 people.
So same is not an option.
No, man, because either one has more and one has less.
They can't be equal.
No, man.
Okay.
All right, Carter. You thought this one had more. Did you tell you which one you think?
I guess I think red has most.
And raise your hand if you think the bigger glass has the most. Raise your hand. I need hands up. Hands up.
If you think red is the most,
Kendra, yes, ma'am. Kendra. Yes, ma'am. Austin. Jordan. Tyler. Anybody? All right. So I got 1, 2, 3, 4, 5, 6, 7, 8. I got 8 people that think the taller glass has the most. Who thinks the smaller glass has the most? 1, 2. All right. 2 people think. Yeah. Xavier and
where you in Haley?
so let's look. Actually, the smaller glass has the most. Look at it.
Wow.
The smaller glass has more water than the bigger glass. Just by maybe an inch or 2. Alright. So, today is my experiment. And hope y'all enjoyed it and hope y'all got something out of it.
So I did my experiment with my daughter. She's 6. She'll be 7 in November. So I had 2 glasses that were the same, and I had one taller glass, taller glass, and she recognized that the 2 smaller glasses had the same water level. Once I poured the water into the taller, thinner glass, she stated that that glass had more water. So then I poured the water back into the smaller glass and I said, look, Melody, I'm just taking this water and then I'm just putting it in a taller glass. And then she understood the concept that just because it's a different glass doesn't mean the water level changes. So that's how our experiment went. She finally recognized just because the glass changed doesn't mean the water level changed.
Doing the liquid volume experiment for the concrete operational stage was a lot of fun. I had an age range between 10 to 5, so it was really nice to see where those gaps were and which children were able to fill in those gaps. My 10-year-old stayed consistent through both his responses when I asked the question of when the volume is transferred into another glass that is slightly wider and taller, does it have more liquid in it or would it be the same? He did say that it would be the same both times. My 6-year-old and 7-year-old at first, one said that it would be less once poured into the bigger and wider glass, and one said that it would be more. That was my 7-year-old. However, once I transferred the liquid, they both realized it was the same amount, and so they changed their answer to it would be the same. My outliner was my 5-year-old who, despite everyone's answers and the information being presented to him, said that they were different and that there was more water in the taller, slightly wider glass. And so it was interesting to see his perception based off of what his beliefs were and not necessarily on the facts that were presented in front of him. Also, it was interesting for me to think about the wording and verbiage during my experiment, as my 7-year-old was autistic. So when I originally asked him, are these liquids the same or are they different? His answer was they are the same and different. And I originally marked him as having the same answer. However, upon the completion of my experiment and talking with his mom, she explained that it was based off of how I worded the question. And when asking him again, is the liquid in both the same or are they different? He said they are the same. And then when I asked him what is different, he said the colors, because I did use green water and pink water. So knowing how to be more concise when answering and understanding what I meant made a big difference. So both the conversation with me and the 7-year-old and with all the kids involved just really showed the range of how kids think and how they process at different stages, and it does match up with the stage that we decided to pick. And it was a lot of fun just having this experiment and learning communication styles and what critical thinking looks like from ages 5 all the way up to 10.
I did the video of the water thing with my son, and I chose the 3 glasses, one all the way full, one semi-full, and one a smaller glass. And I asked him to pick out the one that had the most water in it. And he picked out the one with the most water in it. And I asked him, was he sure? And he said, yeah. I said, because if you're not, we're going to measure them in a measuring glass. And I say, so are you sure again? And he said, yeah. And he just picked that one, and we measured them all out. And he count them. We looked at it right in front of he looked at it right in front of me and said, yep. And then in the last one that had the most water in it, he was like, yes. So he said, I told you. So, you know what I mean? He picked out the right glass with the right amount of water in it, and he picked out the ones with the smallest to the medium to the largest. And that was my experience, my experiment. And I thought it went well myself. Thank you.
Good evening, everyone. My name is Kendrick Slaughter. I started my concrete operational stage with my self-contained students. I had about 13 students from ages 11 to 13. I also included my teacher assistant. I started the experiment by using 2 identical glasses and filling those glasses up with red food coloring and green red food coloring. And I started off asking my students which glass had the most water in it, and they compared the two, and some said the green one had the most, some said the red one had the most. So after that, I took the
glass, one of the identical glasses, and took the water out of that one of the identical glasses and placed it into a larger glass. Then I decided to compare the larger glass with one of the identical glasses and asked them which glass do they think have the most water now. So some of the answers changed, some of the answers stayed the same from the first experiment mental process. So I tallied everything up and concluded with the results, and that was the end of my experiment. Thank you.
As you can see from the results of our conservation of liquid volume experiments, most of the students who were tested fit within the cognitive stage of development that they were in. The outliers that were contained within the experiment mostly came from children who were younger or who had learning disabilities, and those were kind of the outliers of the experiment. The rest of the students pretty much understood the conservation of liquid and how when it was poured from one container to the other, it remained the same once they were given a second chance. Some were kind of above the typical mark and understood it the first time without any hinting or any guidance. And the ones that didn't understand it at that point, once they were hinted in that direction, began to understand. So as a result of this experiment, Piaget's theory of cognitive development, specifically those within the concrete operational stage, is an accurate way to assess children and where they should be within their developmental stage.